Now I'm going to read the statement of the numerical 11.8. And the statement is the highest frequency sound humans can hear is about 20,000 hertz. What's the wavelength of sound in air at this particular frequency at a temperature of 20 degrees Celsius? And what is the wavelength of the lowest sounds we can hear of about 20 hertz? Assume the speed of sound in air at 20 degrees Celsius is approximately 343 meters per second. So, first of all, we have to know about a very important and a critical concept, that is the speed of sound in any particular media depends upon the temperature of the medium. So it means that the speed of sound in any particular medium can be affected by the temperature of the medium as well. So the speed of sound in air also depends upon the temperature of the particles of the air. So if we have to calculate the speed of sound or the magnitude of the velocity of the sound waves at a particular temperature in air, then we can use that particular equation, which you can see on the screen on the Excel sheet. And the equation is Vt is equivalent to V naught plus 0.61 T. And that is T is the temperature in degrees Celsius. So what is meant by Vt? Vt is the temperature. Vt is the magnitude of the velocity of the sound waves at temperature T degrees Celsius. And V naught is a magnitude of the speed or the velocity of the sound waves at temperature 0 degrees Celsius plus 0.61 T. That's the factor. It means 0.61 times the temperature in degrees Celsius. When you add this particular factor of the 0.61 times the temperature in Celsius into the magnitude of the velocity of the speed of sound waves at temperature 0 degrees Celsius, you will get the answer of the speed of sound in air at temperature T degrees Celsius. So for example, here you know that the speed of sound in air at 0 degrees Celsius is approximately 331 meters per second. So when we put the values, the respective values in the equation, we get the answer. For example, Vt is equivalent to V naught, and the magnitude of the velocity of the speed of sound waves in air at 0 degrees Celsius is 331 meters per second plus 0.61 times the temperature in degrees Celsius, which is given by the examiner as 20 degrees Celsius. We get the answer, which is 343 meters per second. So that is the speed which the examiner has mentioned on the numerical as well, as mentioned in the numerical as well. So in this numerical, we have to calculate the wavelength of the two sound waves. And both of the sound waves are traveling with the same magnitude of velocity, and that is 343 meters per second. First sound wave is traveling with the velocity or the magnitude of the speed, which is 343 meters per second, and the second one is also traveling, you can say that propagating with the velocity or the magnitude of the speed, which is 343 meters per second. Our task is that we have to calculate the wavelength of both of the sound waves, and the frequency of the first sound wave is 20 hertz, and the frequency of the second sound wave is about 20,000 hertz. 20,000 hertz is the upper maximum limit of the frequency which the human ear can perceive or can process or can detect. So that is the maximum audible sound. So that is the frequency of the maximum audible sound, which is 20,000 hertz. And 20 hertz is the minimum audible frequency which a normal human ear can detect or perceive or perceive. So we have to calculate the wavelength of both of the sound waves. So I have written the data magnitude of the highest audible frequency which a normal human can hear is equivalent to, I used the symbol F1 and used the symbol F2 for the I used the symbol F1 for the sound waves of the frequency 20,000 hertz and use the symbol F2 for the sound waves with frequency 20 hertz, so that I can differentiate between both of the entities in a distinguished manner. Okay, F1 is equal to 20,000 hertz, magnitude of the speed of sound in air at 293 Kelvin or 20 degrees Celsius. At 20 degrees Celsius. So at 20 degrees Celsius, both of the sound waves are traveling with the same average velocity or the approximate velocity, which is 343 meters per second. Magnitude of the lowest audible frequency, which a normal human can hear, is equivalent to F2, is equivalent to 20 hertz. what we have to calculate? We have to calculate wavelength of the sound wave or the highest audible frequency is equivalent to lambda 1 is equal to, we have to find wavelength of the sound wave of the lowest audible frequency is equivalent to lambda 2 is equivalent to, we have to find. Okay, you know very well, whenever the examiner has given us the data of frequency and the average speed, and we have to calculate the third variable, which is the wavelength, we used the formula V average speed is equivalent to V average, or the average speed is equivalent to frequency multiplied by wavelength in past. So we will also use that particular formula in this particular case as well, which is average speed is equivalent to frequency multiplied by wavelength for the sound wave. For first sound wave, which is the sound wave carries the maximum audible frequency of 20,000 hertz. For the sound wave of the highest audible frequency and its corresponding wavelength, the formula will become, as it is the generic or the general formula, so specific to first sound wave, which carries the highest or the maximum audible frequency which a normal human can hear. So in this context, the formula will become or will change with its specific variables as well, and its variables are f1 and lambda 2. So we replace f1 with the symbol f1 and lambda with the symbol lambda 1. That is lambda 1. Okay. So average speed is equivalent to f1 multiplied by lambda 1. So to calculate lambda 1, f1 is multiplied on the right hand side with lambda 1. So when we shift f1 on the left hand side of the equation, it will be divided with the factor of average speed by putting values. Lambda 1 is equivalent to 343 divided by 20,000 is equivalent to 343 divided by 20,000. We get answer in meters of the wavelength. Okay. Now again we use the formula. We use the same formula, which is average speed is equal to frequency multiplied by wavelength. So specific to that particular second sound wave, the formula will become average speed is equivalent to f2 multiplied by lambda 2. So to calculate lambda 2, f2 will shift on the left hand side of the equation, and by putting values we'll get the answer, which is 343 divided by 20 hertz, and the wavelength of the second sound wave is 17.15 meters. So that is the end of the numerical 11.8. If you have any query, you can contact me for further clarifications. Take care. Jazakallah. Allah Hafiz.